Welcome to Brain Vision.
So we want the first three solutions given that x is in the interval from negative L over 2 to L over 2. So we have to make an observation. We must have psi n for any value of n equal to 0 at x equal to negative L over 2 as well as at L over 2. So these are two conditions we must have. This will imply that for odd values of n, you have to have a cosine solution. So you can check that by looking at the argument of the function. So you can analyze that. You could try a cosine function or sine function when n is odd, and you'll see that a cosine solution will work at negative L over 2 and L over 2. Similarly, when n is even, you can try sine and cosine functions, and this will imply that a sine solution works when n is even. So the next thing is that we want to look at the first three values of n and see what the solutions are, as well as the probability densities. So psi of for n equals 1 is then cosine pi x over L. So if I have cosine n pi x over L, and again n is odd in this case, then a normalized wave function would just be square root of 2 over L cosine pi x over L. And the probability density function is the square of this, and we have cosine squared pi x over L times 2 over L. And we can continue. We go on to n equals 2, and this time, because n is even, we actually have a sine function, but we have sine of 2 pi x over L, and the probability density is the square of this, 2 over L times sine squared 2 pi x over L. And for n equals 3, we come back to a cosine function, but now we have 3 pi x over L as the argument, and we have the probability density as 2L times cosine squared 3 pi x over L. And we can plot these as well as the probability densities, and they look like this, which is just a basic sketch I made. I also illustrated the potential well. So on the left here you have the wave functions, psi. These are the wave functions. On the right here you've got the probability density functions. So notice that the wave functions can take on negative values, and they can pass through the horizontal axis and continue on to negative values, but the probability density functions can never be negative. They can only take on positive or zero values. So when they reach zero values, they bounce and go back to positive values, except for the ground state case, which basically starts at 0, reaches positive values, and then goes back to 0. So I should point out that in these plots, you have negative L over 2 right here, L over 2, and just the same here, you have negative L over 2 in this plot, and L over 2 in this plot as well.